Hi, in this video we're going to be building the application that you see in front of me right here. This application is going to be an ERC20 minter where you can mint some tokens and be able to send them to some recipient somewhere. What's really cool about this application and what makes it special is that it's using account abstraction with Alchemy embedded accounts. It also has all of the transactions automatically sponsored by a gas policy, which means that you don't have to worry about filling your account with gas before you start making on-chain actions. So that's really cool. So what we can see is if I pop open this particular address right here, this is a smart contract account, and you can see that I have no Ether inside here. And right now I actually don't even have the smart account deployed on chain just yet. We just know this is where the smart account is going to go. So right now I have no gas in here, but what I can do is I can go ahead and mint myself some tokens. This user operation is sponsored by a paymaster so that this is going to go through, and you can see my token balance has increased. If I go on chain, I could see that this transaction did go through and I've been minted 100 Minty coin. Great. Okay, so what we can do from there is we can transfer these tokens out to someone else. Now what I want to show you is the login flow. So I have another application over here. This one is in dark mode. There's a little nice toggle over here to go from light mode to dark mode, and I kept this one in dark mode to differentiate the two. Now this one over here is not logged in. So if we want to log in, what we could do is we can use this temp email right over here. I'm going to go ahead and copy it on over. And I'm going to log in with this particular temp email. So an email is coming along the way, so we'll click into that. Here we go. So we'll open this on up. Great. We have a brand new smart contract account over here. That's really cool that this one started with AA as well, which is, maybe account abstraction. That's pretty lucky. So we can go ahead and open this up here and see that on a block explorer, this is a brand new account as well, a brand new address. There's no smart contract code here yet, but when we go to send a user operation, we'll initialize it. You'll also see that there's no gas over here, right? So we can send some operations because it is gas sponsored. So maybe what we can do is we can send some tokens over to this account. Maybe we'll send to this account over here, we'll send, let's say, 25 of our tokens. I have a multiplier over here to multiply that by way, so I can actually send over 25. So that should leave me with 75 over here on this account. And then over here, I'm going to go ahead and reset this so that we can see our new token balance is now 25. Awesome. And over here, I could do the same thing. I can mint myself some more tokens so I can increase my balance to 125 and maybe send some tokens back the other way. So you can see now I have 125. We could go check this out on chain. There is my Minty coin that's been minted to this address. So if we actually go to that address here, we could see I have 125 Minty coins. You could also see that I have contract code here because now this is a fully deployed smart account. Great. And still no gas in here, right? Because these are all gas sponsored user transactions, which is really awesome. The fact that you can just come in here and as a user, be able to click into an application and start doing things on chain. That's a really exciting thing about gas sponsored operations. So great. What I'm going to do here is I'm going to go ahead and send back to the original user some tokens just to show that one final time. So I will copy this address over here and I'm going to go ahead and send 125, multiply that by way, and we'll send that back on over. This should decrease my token balance over here to 0. And I can come back over this way and I should see that this does increase to 200. Awesome. Okay, so that is the application that we are going to build. Next, I'm going to show you how we're going to build it from a basic starter app. Okay, so let's get started with app development. So what I'm going to be starting from is a template repository. It's called Scaffold AA. So this is actually a fork off something called Scaffold ETH2. I would definitely check out Scaffold ETH2. It's an awesome prototyping tool for any Web3 application that you are trying to build. Scaffold AA is going to be a fork of that. It's going to use embedded accounts. So right out of the gate, we're going to have some really awesome components built by the folks that have built Scaffold ETH2, but with embedded accounts sort of baked right into the application. And you'll see what I mean in just a moment. The other two tabs I'm going to keep open. One other thing I should mention before we get in is I will link down below what commit of Scaffold AA I am using for this video. So in case you want to follow along, you can use the same commit. because otherwise you may find that the code base is slightly different. I'm definitely going to be improving this over time, so it may not be the exact same instructions if you're trying to replicate exactly what I'm doing here. So that is Scaffold AA. You can find it here, github.com/Alchemy Platforms, Scaffold AA. Check it out. So that's what we're going to be using. The other two tabs that I wanted to point out here is Scaffold E2. So you could still make use of the documentation from the Scaffold E2. You're going to see all the components and React hooks are going to be the same with a couple additional things inside of them, but I tried to keep the API pretty much the same so you could use the same documentation here. And that's what we're going to be doing in this video. So I'll show you what I mean about that in a moment. Finally, the last thing I have here is DaisyUI. I have open because that's what Scaffold E2 uses. It's a component library built on top of Tailwinds. So we're going to be using this component library for a couple of the components that we're going to be building in this video. So definitely check out DaisyUI and I'll show you which components we're going to be building. So I'll keep these two open because they're going to be very useful to me in a moment. And then we'll go ahead and jump into the coding. So what I did is I already cloned my Scaffold AA here and I called it Scaffold AA ERC20. And what I'm going to do to get started is just go ahead and run this. So one thing that I did do before I did this is I installed the dependencies. I also created my .envs. So you'll see that there's a sample.env in both the hardhat and the Next.js packages in here. So you see these two packages. Next.js is going to be our front end and also is going to have some API routes. And then we're also going to have hardhat, which is going to be where we're going to be deploying our contracts from. You'll see that there's a env example. You need to copy this and create your own .env to point at an RPC node. And to also get a gas policy. So I'll put in some instructions in the repo in case you want to do the same thing. Okay, so with that, we'll get underway. One of the ways that you can start a Scaffold ETH project is by just running yarn start, and you can find this in the README. It'll explain exactly what you need to do here in order to begin, in order to install everything with yarn, and then to be able to actually run the repository, to deploy the contracts, and to run the repository. So I just want to show you what we have when we run yarn start, what that begins us with. So if I go ahead and open this localhost 3000, it's going to kick off the application. We'll see what we're beginning here with. Like I said, it's a fork off of Scaffold ETH2 with the addition of Alchemy embedded accounts. So a couple things that you're going to see here when you first come in to the gate is a big login button over here on the right hand side. You'll notice that our connected address is, it just shows it kind of loading because we don't have a connected address just yet. You'll notice that we also have this little component down here that's actually grabbing the price of Ether mainnet. So that's actually going out to the mainnet chain there. And then we'll be using Arbitrum Sepolia specifically to be deploying our contracts, and you'll see that as we go in. So there's this debug contracts tab, which is going to be useful to us if we log in. So what I'm going to do is throughout this video, I'm going to make use of a service called tempmail.org. And what this is going to allow me to do is get a temporary email address that I can go ahead and pull over. So that way, you know, I am starting from scratch. It's a brand new email address. I can pull this into my account and say send email. So this email is going to come on over. And then we can click in over here and jump into my application. Okay, there it is. Great. So we can just have one of these tabs open. Now you can see I have a brand new address here. That's going to be my smart account address. And what I can use this for is sending some user operations. So if we actually go over to this debug contracts tab right here, we can go in here and we can see that there's already a contract that's been deployed. This is from my previous runs of going through this repo. So this contract is already in here from my Scaffold AA. But if we wanted to deploy a new contract, we could totally do that by coming back over here and doing a new terminal. And this again is also going to be in the README. You could just run yarn deploy. Specifically for us, we're going to be deploying on Arbitrum Sepolia because that is the testnet that we are using in this case. That's what the chain is configured to use. So I'm going to be saying yarn deploy network Arbitrum Sepolia and go ahead and deploy our contracts out there. So that's where we'll be sending them. We'll be creating a new version of your contract. It's going to set the initial greeting to build unstoppable apps. And sure enough, if we come back over here to our front end, it's already actually refreshed It's kind of hot reloaded. So we can see that there's this greeting that says build unstoppable apps. We haven't set the greeting yet, so the total counter is 0. So what we can do at this point is set the greeting. Say hello world, right? And just send that on in there. And hopefully that'll go ahead and update the greeting there. You can see that it's sending a user operation. So even though this is a brand new account, I didn't need to put any gas in there because I'm sending a gas sponsored user operation. So if we were to pull this up over here, you can see that this is a smart account. There is contract code here, but there is no ether balance. I don't have to maintain a gas balance there, which is super nice because we're doing the gas sponsorship. Okay, great. So we set a greeting on our contract. This is what we get out of the gate with Scaffold AA. So you can do this yourself. You can pull down the repo and you could be able to do something very similar once you run those commands and you set up your .envs the way that you need to. Follow the README to learn more on that. Once you have that set up, what we want to do is we want to actually start to build our application, right? And so to build our application, what we can do is we can first write a smart contract. And the smart contract that I'm going to want to write is an ERC20 contract. And so we're going to redeploy that as a new contract over here. So let's just go back to our hard hat repo. I am just going to clear all the previous deployments because I'm going to deploy a brand new contract over here. The contract, let's just close this here. The contract is going to be ERC20. So fortunately, they left in here in the comments Open Zeppelin, and it's already installed in here. So the contract that I'm going to want to actually get is underneath token. And let's see if this auto completes it for me so I know I'm doing the right thing. Nope. Contract / token / ERC20. ERC20.sol. Awesome. That's what I wanted. And I don't need any debugging. This should be a pretty straightforward contract. What this contract is going to be, I'm going to call it super mintable. It's going to be an ERC20. And why I call it super mintable, you'll see in a second. It's super mintable because we're going to make it so anyone can mint this ERC20 token. Makes for a pretty fun demo. So what we can do is we can come into our ERC20 contract here and take a look at the function mint. So there's this underscore mint function here that's internal. What we can do is we can go ahead and just be able to call it from an external function if we would like. So I'm just going to copy this over here. I'm just going to basically create a similar function, call it mint, but this one is going to be external. And I'm just going to go ahead and call the internal function. Could also override it. This is just going to be easy enough. I'm just going to go ahead and send that over there. Okay, so great. So now we have our super mintable, and we could call mint, the internal function here. What I'm going to also do is you'll see that it's yelling at me. It's saying this should be marked as abstract. That's because I haven't implemented the constructor here. So the ERC20 has a constructor that looks like this. We want to do basically the same thing. We want to take a name and a symbol, but instead of just putting this here, I'm just going to pass this along to the ERC20 contract constructor like this. So I'll just pass those along. And then we'll be able to establish the name and the symbol of our super mintable ERC20 contract, and anybody will be able to call mint. Awesome. So what we're going to go ahead and do is we're going to change our deploy script. So our deploy script, instead of deploying your contract, is going to be deploying super mintable. The arguments for this are going to be the name of the contract, we'll call minty, and the symbol we'll call mint. And then we don't need to call this to look up the greeting. We'll just go ahead and deploy the contract. This is going to go ahead and create all the typings for this contract, and it's also going to deploy it and put it in a spot where our front end can access it and be able to show it to us automatically. So we'll go ahead and deploy this one, and let's see if it works. Deploying super mintable. Looks like it's updating my front end. So hopefully now we can come out here and we see super mintable. There is our contract. You can see the total supply is 0. Nobody has minted it. But if we want to mint some to ourselves, we can go ahead and do that. So we can take our address up here. We can copy it. We can approve. No, that's not what I wanted to do. we can mint. There it is. Okay, so I'm getting the same little icon that I have up here, up at the top. So that's me. What I'm going to want to mint to myself is, let's say, 100 tokens. So I can multiply that by the number of decimals, 10 to the 18th. And hopefully now, if we take our address and go up to the balance of function, we should see that we have 100. The other thing you'll notice is updated is the total supply here now says 100. And we could test this again by doing maybe like this time, let's just do 25 and multiplying that by the decimals. And then hopefully now we'll see that the total supply goes up to 125. Did that automatically. And then we have 125 the balance of here. Awesome. Okay, so that is us updating the balance for the mint. Something that might be kind of interesting at this point is maybe doing a transfer. So maybe we want to have another address that we actually transfer some tokens to. So maybe it would be fun to actually introduce another account at this point. So we could do that. I'm going to open up like an incognito window here and do another temporary email. So let's go ahead and grab this one. As soon as that loads. In the meantime, I will go out to my local host, pull that on up, and you'll notice in my incognito, I'm already in dark mode, which is cool. So this will help us remember which one I'm in, whether it's the incognito or the light mode, which is the other one over here. Let's pull this on over here so I know it's over here. So, okay, so incognito, what I can do is I can go ahead and send over my email address. Now an email should come over here. And we go ahead and sign in. And we can keep one of these windows open, and we got ourselves a smart contract address. So this is where our smart account is. Now, if we actually want to get some tokens, what we can do is we can first just check. We should have no tokens, right? There's 0. Notice the total supply is saying 125 because we're referring to the same contract here. If I bring this on over to my other account, what I can do is I can transfer to them. Maybe let's do 27 tokens, right? So what that should do is it should take away, I should now have 98. The total supply should stay the same, but if we came back over here to the balance of this account here, now I should see that it's 27, right? Okay, awesome. So another thing that actually gets people confused quite often is the approved transfer from flow. So this is really useful for when you are trying to transfer using a smart contract. So like, let's say that you are trying to put your funds in a Uniswap pool or something like that. A smart contract, what you can do is you can approve that contract to be able to spend some of your funds, and then it transfers from you into the smart contract. That's just something that's needed for the ERC20 smart contract flow. It's a little bit easier to see it in a diagram, but trust me, that's just what's needed inside of ERC20. I think something that's kind of helpful here to see is to see that in action. Even though we're using 2 addresses here that are just being used as accounts, it may be helpful to see that approved transfer from flow here. So what we can do is we can come back over to this account here, and we can approve the other address. So this one here, we can approve this one to spend some of our funds. So let's go ahead and do something like that. We're going to do increase allowance. We're going to increase the allowance of this person by, let's say, 26. So we'll give them 26 tokens that they can spend from our account. So that went through. This does not change my balance. So this should still be 98 because I spent 27 of those 125s. So I still have 98 in here, but I've given 26 over to the other account that it can spend from my balance. So what I can do is I can take this address over here, copy it on over, and I could say transfer from that address to my address. So now I'm spending their tokens and I'm sending it to myself. I can say, let's do 13 because that's going to be half of the 26 that I was allowed. And I could say 13. This first user operation should work. So we should see my balance automatically increase to 40. And then if we did it again, we should see this work going up to 53. But if we tried it one more time, insufficient allowance, right? We no longer have the allowance that we need in order to be able to pull those funds from that account. So we got to see that approved transfer from flow, and we got a pretty good error message when it failed. Awesome. So that is the contract working. We have this debug contracts tab. But if you were going to give this application to an end user, you wouldn't want them using a UI that looks like this. It's not the worst UI in the world, but it's not one that's super user-friendly. So that's what we want to do next, is create a user-friendly UI for users who are trying to mint and transfer tokens to accounts. So let's go ahead and do that. So the first thing that I'm going to do here, I'm going to be running this mostly on this account here to kind of change everything. So one thing that I'm going to do first, let's get rid of this debug contracts tab. I'm pretty satisfied with my contracts, so I don't need to debug it any further. So let's go ahead and do that first. So I'm going to go ahead and say debug contracts. I'm going to search this. Let's see where it is. So this is in the header. So this is where the header tabs actually come in. I can go ahead and delete that one. So now we only have home. Great. And we'll get rid of the unused import there. And then the next thing that we're going to do is I'm going to get rid of this footer that says the fork me, and let's keep the dark mode light mode. That's kind of nice, but I don't need this little ether price thing here. So we'll get rid of most of the things that we just don't need. So there's a place where, actually it should just be called footer. Okay, so for the footer, the only thing that I really want to keep in there is the switch theme. So I'm going to get rid of everything else, just so we can get all the way back to the bare bones, right? This is your app that you can play around with, so feel free to just rip stuff out. At the end of the day, you're gonna have components and hooks that you can use, but the actual like page and the footer and the nav bar, that's all for you to mess around with and play around with once you're ready to go and start building your application. So I'm gonna get rid of basically everything in the footer here except for that switch theme component, which was nicely put in there for us. So one thing that I might do though, is I might just fix it to the bottom right there. So I'm going to say that this is position fixed. These are tailwinds classes. I'm going to go ahead and say right 4 and bottom 4. So that seems like a good number. And hopefully, yeah, there it is. Right? Okay, so we still got that. We got rid of the rest of the footers. Next, I'm going to get rid of all this stuff on the page. So welcome to Scaffold AA. Let's go ahead and get rid of that. So welcome to... Cool. So this is our main home page here. So what I'm going to do is I'm going to get rid of like everything. And we don't really need these empty outside brackets either. And we'll just say like, hello world. Let's see. Okay, great. So it says hello world. Now what I want to do is I want to actually show the balance of this account, right? We should have, I don't know, we spent 26 from 98. So now we should have like 72. If my math is correct and my memory is correct, we should have a balance of 72. I want to see if if we can actually show that. How hard is it for us to go look up that balance and show it on the page in a user-friendly component? So let's go ahead and we have this hook right here, this use account. This is actually going to come from our React hooks from the Alchemy account kit. So this right here is going to give you access to this account. And on this account, it's going to have the address. So we can say something like, account.address. Part, you won't have to look up too many of these hooks, but if you needed to, like for this use account here, and you needed to look up these hooks and be able to use this account from the Alchemy account kit, you could actually go out to accountkit.alchemy.com and you could jump into the docs here, and you're going to see down here there will be React hooks. And so use account is documented right here. You'll be able to see everything that you need in order to be able to use that account. So in this case, we're just using it to be able to grab that account address. The account possibly could be undefined here, so we're just going to put that there. And then we see the account address. It's the same one that's up here in the top right and the nav bar up here. Great. Okay, so that's the only hook I know that I'm going to need to use from the account kit. We're going to get the address. Now everything else is going to be hooks from Scaffold Ether. So if I actually go out to the Scaffold Ether documentation, we're going to be using the same hooks that Scaffold Ether 2 has, but they're inside of them is going to be all the logic to be able to run gas-sponsored user operations. So what you can do is you can come in here to use these same hooks. You could say use Scaffold read contract. This would be helpful here because I want to read the balance of this particular address. So let's go ahead and use this one. Plus, it's also going to have this watch parameter that's going to default to true. which is nice. So automatically it's going to watch when there's new blocks that comes in, it's going to go ahead and update that balance for us. So that's super sweet. Let's go ahead and use this. So we're going to say use scaffold read contract. So what's really cool too here is that it's actually going to pull in the typings. So it's getting mad right now because there is no contract called your contract that I've compiled, right? We have a super mintable. So that's what it's actually telling me in the error right there. It's saying it's not assignable to type super mintable. That's the only one that it knows of. So I'm going to pass in super mintable. That's the only contract it knows. And then I'm going to pass in mint. That's going, no, that's not what I'm going to want to use here. I'm going to want to use balance of. And I'm going to be looking up the balance of our account. So the account dot address here. And this could also be possibly undefined. And then this is going to be our balance. And we're going to want to show the balance in our application right here. Great. So this balance, it says, is not assignable to React. Let's just turn it into a string for now. Or you know what, even better, I think this is going to come back as a big int or undefined. So what we might want to do is we might want to format this. And we could use format ether from VM to format this. Because if it's coming back as a big int, it's going to come back as a very large number. So we could say format ether or 0, and if there is no balance, if it didn't come back. So hopefully now we should see our balance, which is 72. So it looks like memory served quite well there. 72 is what we are getting. So awesome. So what I want to do is I want to actually start showing this nicely on the page. So the next thing that I'm going to do is I'm going to actually go into DaisyUI and start using some of the components from here. So one of the components that I think is going to be helpful is I believe there's a component called stat. Let's see, there it is. Okay, awesome. So this component here is going to allow us to show something that looks nice, like this. And this is going to be our balance. We're going to want to show our balance. And this is actually the most, keep clicking that and brings me up the dictionary. This is going to be the most useful one right here because it has buttons already baked in. So let's just go ahead and use that. I'm just going to pull over this stat right here. And inside of here, we're going to want to show the stat is going to be your tokens, so how many tokens you have, and then we're going to show your token balance here. And then we are going to have a button, but it's going to be called mint, and then we could like just mint 100. That way we don't have to accept. We could just go ahead and just mint 100 every time that they want to ask for 100 more or whatever. Keep it really, really simple. And we need that format ether there. Okay, great. So now let's just see that this is looking nice. Okay, it looks all right. Maybe we want to center this, put it in like a card. So there's also these cards that's going to show up in the data display. So this is another thing that we can use. So yeah, this looks pretty cool. Let's do something like this. So I'm going to do, yeah, let's just wrap it in this one here. So I'm going to wrap my stat in a card, put this up here, and let's see how that looks. Okay, awesome. And it's already centered. That's perfect. So now we have 72 tokens. And, well, let's just try minting. No, I didn't write the function mint. So we need to go ahead and write the function mint. So let's go ahead and do that. I'm going to call a function called mint. And we're going to say async function mint. And what we're going to do in here is we're going to use another scaffold hook. But this one's going to be called use scaffold write contract. So this one, again, is going to pull from our contracts that we've compiled so that we can get all the types and everything that we would want to be able to use with these different hooks. So I'm going to go ahead and say, so let's do use scaffold write contract. And the write contract that we want to get is going to be called super mintable. There it is. You saw it autocomplete for me, which is super nice. And then there's these functions. There's write contract and write contract async. I'm going to use async here because I want to actually get the promise back. And then we could actually refetch our balance. Although this should be watching, but if we want to do it like right away, we can actually pull from here. There's a refetch that comes back, and this is a function that I can call when we've completed our mint, so we can refetch immediately. Otherwise, we're just going to watch and wait for the next blocks to come in, And that may take a second or two. And I want to show the user right away, hey, look, your balance has changed because you've minted some tokens. So great. So we're going to go ahead and say write contract async. This is going to take a few methods. And again, you can find the documentation on all of this on Scaffold Ether. So if you want to go to use Scaffold write contract, you can see that it's calling this write contract async. You pass in a function name, args, and value if you need it. We don't need a value in this case. We're not passing any ether. So we're going to call mint, and we're going to pass in our args, we're going to pass in, who do we want to mint it to? We want to mint it to our account.address. And then how much do we want to mint? We said mint 100 down here, right? So let's just go ahead and mint 100 for no surprises. So let's go ahead and do that. So we'll do a parse ether from VM here as well and pass in 100. Cool. So this should about do it. I also, because this is going to come back with a promise, I can do a .then and then just call refetch here, which is going to be nice. That's going to just automatically update, or well, not really automatically, right? It's going to go and fetch the latest balance, but instead of waiting, we'll just get it right away. So it'll look pretty instantaneous, and that's what we want here, right? So let's go ahead and do that. We're going to mint 100 tokens, and then hopefully once the user operation lands in a transaction, 172, boom, right? And if we want to do it again, maybe we could see that's 272. Sweet. All right, cool. So we got ourselves a mint function. That was really, really fast. So now what we want to do is we want to get a transfer function. So these are the two things that I want to do. I want another card where I can transfer some tokens over to the other account so we can kind of see that interplay between these two different accounts. So that's what I'm going to do. I'm going to create another card. I'm going to basically copy, well, no, let's just create another card down here. And then inside of this card, if we go back to the Tailwind DaisyUI, we can see in here there's like a card body. And the card body is going to be kind of similar to what I want for this one. So the title is going to be transfer tokens. Whatever, I don't need a P. But the button, what I want to put in here is transfer. All right, we want to call transfer. And we're going to want two things in here. But let's just make sure this renders okay before we do anything else. Okay, it looks all right. We're probably going to want to put some margin up there. So I'll do like a MT12, put a little margin top. Okay, so now what we're going to want to do inside of here is we're going to want to put a couple things, right? When we're transferring tokens, what do we need to know? Who are we transferring tokens to, and how much are we trying to send to them? So that's what we're going to have to put in here. So who are we passing it to? Fortunately, there's a really useful component in Scaffold Ether and in Scaffold AA that you can use called an address input. Now you can find these different components. They're going to be, so I just included it, so you'll find it right here. It's in hooks, Scaffold ETH. Oh, sorry. Components Scaffold ETH. It was this one right here. So you can actually find that if you go to components and then you go to Scaffold ETH, you're going to find quite a few different components that you can use in here. In this case, we want to use the address input, but if you needed to pass in any of these other inputs, you could take these as well. So the address input is going to be really useful for me here. So let's go ahead and take a look at why. So the address input, the other input that I'm going to want to use is the amount. And for that one, there's an integer input that is actually going to allow me to do that multiplication that you saw me do before, where you can multiply by the number of decimals. So for these inputs, the address and the integer input, I believe, so let's take a look at what they require. The inputs is value and on change. The other ones are all optional. So I am just going to use value and on change. So we're going to have to put something in the value, and then we're going to have to put something in the on change here. The on change is going to be a function. The value is going to be a piece of state that we're going to pass on down. The other thing that we might want to do is wrap these in labels just to make it look a little nice. And we'll do something like that. I'm sure it won't look that great, but at least, it's something. So we'll say amount and we'll say recipient, something like that. And then for the value and the on change, now what we're going to want to do is we're going to want to create some state hooks. So for the state hooks, I'm going to create a recipient set, did not spell that correctly. Recipient set recipient is going to be useState. And we're going to pass in here, I don't know, an empty string. And we'll do the same thing for amount and set amount. And we'll see if the string is good. All right, so we'll take those two down here. We're gonna pass into the address, the recipient, and we're gonna pass into the amount, and then on change, this is gonna pass a value, and we'll say set recipient value. And then same for the amount, the value, and then we're gonna set amount to the val. All right, cool. Looks like it's complaining. It says string or big int is not assignable to string. So it looks like this integer input, depending on which side you toggle it to, it'll either come out as a string or a big int. So that's surfacing to me. So I'm going to handle it up here inside of the amount. I'm going to say string or big int here. And we'll just have to handle that ourselves. So now we have that typing set up properly. Okay, great. So now what I want to do is I want to do on click, we'll do a transfer. And transfer is going to look a lot like mint. We're going to want to refetch at the end to make sure that transfer went through properly and we got the balance change. We're going to call this transfer. Transfer also takes, I believe, these same arguments. So if we go back up to our contract, ERC20, transfer is going to be function transfer. An address to and a uint amount, which I believe is the same thing as what we were doing over here. So if we go back to our page, this is what we were doing in the mint case too, was we were doing an address and an amount. So in the mint case, we were saying give these tokens for free to this address, and transfer, we are actually transferring from our account to this person, but it takes an address and a uint in both cases. Okay, so in this case though, we're going to want to pass in the recipient and then the amount. Cool. And it's complaining because string or big int, it's expecting a big int. So we're going to want to say big int. And whether the amount is a big int or a string, passing into this big int here should resolve okay. So it looks like it's happy now. Okay, great. So that might be everything we need to do here. So we can come back over and we can start transferring some tokens. Okay, let's see if this works. We still have that incognito tab over here. Unfortunately, the session timed out, so we're going to want to log back in. So let's go back over here to get the address for this person. Great. So we'll pull this on over and we'll log in, send that through. New email coming any moment. And we will go ahead and log back in. Great. Cool. Okay, so we have our 53 tokens on this account. What we want to do is send over some tokens from this one to this one here. So let's go ahead and do that. We'll copy over the address and let's make it a nice even number on the other side. So 53 will pass over 47. We'll multiply that out and transfer. Send the user operation. It should show us a removal of 47, so 225. And then over here, now this may take a second because it's like waiting for the block to come through and then it's going to watch, but there's the 100. Great. Cool. So now we have 100 tokens over here. And if we want, we can mint 100 and we could send maybe some back. So let's go ahead and copy this address over here. And maybe we could send over 150 because we're feeling generous on this side. And then we'll send these back on over. And so we should see this one update as soon as the user operation goes through. So 150 minus, now we have 50. And then over here, I think that already updated, right? 375. Cool. Yeah, looks good to me. Mint some more tokens, send them back and forth. That's pretty fun, right? We created a pretty nice user-friendly application in a short period of time using Scaffold AA. So hopefully you enjoyed that video. Try out Scaffold AA for yourself. Like I said, if you follow the commit below, you can get the version that I was on. But otherwise, you know, you could find the latest version, which probably has even better updates It's probably even smoother than it was before, and you should still be able to follow along with the scaffold ETH2 documentation to use those same hooks that I did. Use scaffold write contract, use scaffold read contract, all that sort of stuff. So hope you enjoyed the video, and get into scaffold AA and start building some awesome applications with embedded accounts.